gentlemen, welcome to another episode of Savage Wilkie
and Ellis
Productions. Mr. Savage, what are we up to today?
Today we're going to be looking at index laws.
Wow, index laws. They sound exciting.
Yeah, they're pretty cool. First off, we have to understand what does that word mean? What does that index mean? And it refers to when we have a number that has a power on it. So it's just a fancy way to say the power of.
Oh, okay. Well, that does sound pretty impressive.
Yeah. So two things we need to know before we jump into a few of the operations. We have what's called the base. Now that's our base number, the actual value that's being multiplied by itself. Now this little number up here, the power, is what we're going to refer to as the index.
Okay, so what does the power do in terms of the base? That 3 up there, what does it do to this 2?
What it means is that the number 2 is multiplying by itself 3 times.
Because there's a 3 up there.
Exactly.
So if there was like a 5 up there, it would be the number 2 multiplied by itself 5 times.
Exactly.
I think I get it. Okay, so Mr. Savage, there are a number of these index laws. What's the first one?
The first one and the most simple one is what we call the zero law. Now this one is all about remembering. So let's have a look at these 3 examples here. I've got the base of 3 and the index of 0. And now that number actually equals 1.
So 3 to the power of 0 equals 1.
Right.
Okay.
So the second example, 100 to the power of 0 also equals 1.
So 3 to the power of 0 equals 1, and 100 to the power of 0 also equals 1.
Exactly.
I see.
Now this number over here, 7,584 to the power of 0 equals
1.
Yeah.
I think I'm starting to see a pattern here. Sir, correct me if I'm wrong, but I think if we've got any base here to the power of 0, the answer is always going to be equal to 1.
That's it. That's the zero law.
Super stuff. So the second index law that we've got, Mr. Savage, is the multiplication law.
That's right.
How does that one work?
So that's when we have 2 numbers that have the same base, but they could have different or the same indices, and they multiply together.
Okay, all right. So, for example, 4 to the power of 2 multiplied by 4 to the power of 3, they're both base 4.
Exactly.
Okay.
As long as they've got the same base, we can use the multiplication law. Now the way that works is we actually take the 2 index values, the 2 and the 3, and they add together. Now, note that the base stays the same. So we actually end up with 4 to the power of 5.
There you go. So all we did, the base stayed exactly the same, and we just added our 2 indices.
Exactly.
Sounds easy enough. Have you got another example there for us?
Right here. So we've got 7 to the power of 4 times 7 to the power of 5. So when you see that multiplication symbol between the 2 numbers that have the same base, you add the indices. So we're going to add the 4 and 5 there to get a solution of 7 to the power of 9.
That sounds incredible. So really, when I'm multiplying any 2 numbers with the same base, all I need to do is add the indices.
That's right.
Sounds good. Okay, Mr. Savage, so our third law, possibly my personal favourite, is the division law of indices. And how does that one work?
Very similar to the multiplication. So we must have the same base between the numbers, and then we're only dealing with those indices. So when we see that division sign, we're going to actually subtract the first index, second index.
So a bit like opposite of the multiplication law, where we're adding. In the division law, we subtract.
Exactly. So you can see in that first example there, I've got 10 to the power of 6 divided by 10 to the power of 2. I show my working by subtracting the index. 6 take 2, giving me a solution, 10 to the power of 4.
Fantastic. And you'll notice as well that that base does not change. We just do a little bit of work with the indices.
Exactly.
Could you talk us through that second example you got, sir?
We've got 8 to the power of 7 divided by 8 to the power of 5. So once again, just looking at the indices, 7 take away the 5, giving me the answer of 8 to the power of 2.
That's fantastic stuff. So when dividing any numbers that have got the same base, we simply have to subtract the indices.
That's it.
Awesome. Okay, so Mr. Savage, this brings us to our final law in indices. And what's this law? Yes, he does. So this one is the power of a power law. And how does it work, sir?
So in this one here, we've got our base with our index, 5 to the power of 3. Now it's in brackets and there's a power being applied to that entire number, so to the base with the power already.
Okay.
So in this case here, we actually take the index we already have and the new index, we multiply them together. So in the first example, 5 to the power of 3 taken to the power of 2 ends up being 5 to the power of 3 times 2, which equals 5 to the power of 6.
Okay, fantastic. So we're simply multiplying those two powers and we don't adjust that base at all.
Nope.
I see how it works. Have you got another example there for us?
Second one here, we've got 9 to the power of 4 to the power of 3. We take the two powers and we multiply them together. 4 times 3 equals 12, giving me 9 to the power of 12.
As simple as that. So anytime we're applying a power to a base that already has a power, we simply multiply the two powers together. Multiply the indexes, leave the base the same, and there's our final answer.
That's it.
Ladies and gents, I hope you can do now all of those index laws.